Hello class, we are going to start studying logarithmic functions today, and you'll see how they are very closely related to exponential functions. Okay, so we're looking at investigation 5 on page 407 in the textbook. So a good idea to take that out, follow along in that, and you'll be able to take some notes as well. Okay, first thing we need to do, number 1, plot f of x is equal to 10 to the power of x and g of x is equal to log base 10 of x. So we get our trusty little graphing calculator out here, and we are going to input what we need to input. So we will go tab 10 to the power of x, enter, and we get this graph right here. And then we're going to tab, add a second graph, log. Now the log button is on top of the 10 to the power of x button. So you're going to go control and then that button to get log. And you'll see up here we have a little box to put in what the base is, and that's 10. And then we move over and we have a box to put what else we need there, which is our variable in this case, which is x, and enter. And we get these two graphs. Okay. So let's transfer those quickly onto our board here, which I already did. And you might already notice a little bit of relationship between the two from something we've studied previously. Okay, so let's talk about number 2, the domain of f of x. So we've already studied exponential functions. This is an exponential function, and so we know the domain for that function, the smallest x coordinates, negative infinity, largest coordinates, infinity, and also every number in between. So we can write that in this way, negative infinity to infinity, okay? Curve brackets on the outside because not equal to infinity, not equal to negative infinity, just because we can't equal that. Or we can write it in the other notation, which would be x is an element of real numbers. Okay, so choose which notation you're using, remember. The range of this function, the smallest y coordinate on our blue function, is almost 0. So but never actually 0. It's going to keep on getting closer and closer to that x-axis, but never touch it and never cross it. So that we're going to say the range there is almost 0, okay? Not equal to 0 though, and all the way up to infinity. The other way of writing that is y is greater than 0. Okay. Now, we'll talk about the domain and range of our g function in a moment. We're going to come back to that one. Okay, let's plot y equals x. Plot y equals x, that's this diagonal line. Okay, y equals x. And hopefully you can now see what that relationship is. These two functions are actually mirrored on that line, y equals x. And we've studied inverse functions before, so that then tells us that this is an inverse function. Okay, so number 5, what does the line y equals x tell you about the functions f and g? Okay, they are inverses. They reflect each other in that line. In the line y equals x. Okay, so number 6, what is the relationship then between exponents and logs? They are inverse functions of each other. All right, number 7, how can you use the domain and range of an exponential function? Okay, so remember our blue one is the exponential function. How can we use the domain and range of that to state the domain and range of our logarithmic function? Okay, so down here, if you remember, let's just pick the y-intercept here of our exponential function, and that's going to be 0, 1. And when we inverse that point, reflected in y equals x, that point becomes 1, 0. So that's just a reminder that everything, when we're dealing with inverse functions, everything that was an x becomes a y, everything that was a y becomes an x, okay? So you can see that those coordinates, those two ordered pairs, their x's and their y's traded places. So therefore the domain of the g function is going to be the same as the range of the blue function, okay? So that domain of our red function, the smallest x coordinate going right and left, is almost 0, not quite 0 though, and the largest x coordinate is infinity. So we can write it like this, or we could say, nope, not y, it's x. X is greater than 0. Okay, the range for this function will be the domain of the original function, the exponential. So the range all the way down to negative infinity, all the way up to infinity, and we'll keep going. And so we can say negative infinity to infinity, or we could say y is an element of real numbers. Choose which method you want to use for your notation for domain and range. Okay, what graph do you get when we reflect? Actually, I'm going to come back there because asymptote. We were also supposed to look at the asymptote. Okay, so the asymptote of this blue function, and this is a horizontal asymptote of our blue function, the exponentials. We already know that. It's a horizontal asymptote. And it is the x-axis, so it's y equals 0 is the equation of that asymptote. So remembering again that all things x becomes y, all things y becomes x when we do the inverse. So on this logarithmic function, our asymptote is actually a vertical asymptote, so a straight line up and down. And that, in this case, is going to be x equals 0 as that equation. So that's the y-axis is the asymptote for that function. Okay, number 8, what graph do you get when you reflect f of x equals a to the power of x in the line y equals x? So our example that we actually did was 10 to the power of x. Now we're looking at a to the power of x. So we're talking about any base, just in general, a base to the power of x. So let's see, how does that reflect in y equals x? Well, let's find the common things here that are happening. We're talking about, that's our base, we're talking about that now being a, okay? And our base came over here as the base of that logarithm, okay? So we could say it will become f inverse, let's use the inverse notation, okay? Remember that inverse notation, -1 as in the exponent position of the f, but it refers to inverse function, will equal log, the base is a now, of x, okay? So very close relationship between exponents and logs.